Hey everyone, welcome back to another lesson in MCR3U. Today we'll be looking at the radical function and its translations. So let's start with the radical function, and the radical function is represented as f of x is equal to square root x. And so here, f of x is equal to square root x here will be our parent function. And so this is our parent function. And all the transformations that are applied to this value of square root x. So here, this first part says to graph the function y is equal to square root x by completing a table of values. So here, we'll have our table of values, we'll have our x and y. Here, the values that we'll sub in are 0, 1, 4, and 9. And here, if we square root 0, we'll get 0. If we square root 1, we'll get 1. If we square root 4, we will get 2. And if we square root 9, we'll have 3. And so here we have a graph that's provided for us on the right, and we're going to plot these points. So here we'll start at 0, 0. At 1, we'll be at 1. At 4, we will be at 2. And at 9, we'll be at 3. So here the radical function will look something like this. And here it says, why does the graph y is equal to square root x appear only in the first quadrant? Remember, if we look at the quadrants, quadrant starts on the top right and then moves counterclockwise. So that's quadrant 1, that's quadrant 2, quadrant 3, and quadrant 4. And again, why does the graph of y is equal to square root x appear only in the first quadrant? The reason this is the case is because you cannot square root a negative number so you can't square root a negative number. And so here, since positive square root always gives you a positive answer. And so therefore, we see here that x has to be greater than equal to 0, and y has to be greater or equal to 0. And so here we see that the domain for y is equal to square root x is x is greater or equal to 0, and x is an element of real numbers. If we want to look at it in terms of interval notation, it'll be from 0 to positive infinity. And here, does the value ever reach a maximum? And here, it doesn't reach a maximum as x continues to increase. So here, we'll say no, since x continues to increase. So since x continues to increase, and so does the y values. So here, you might think that there's an asymptote at that point of around y is equal to 3. However, there is no asymptote because it actually still is continuing to increase. So here, again, we'll write looks like an asymptote. So it looks like an asymptote, but is not. And here, look at what is the range of y is equal to square root x. So here again, also y has to be greater or equal to 0, and y is an element of real numbers. And again, interval notation here. Again, it'll go from 0 to positive infinity. And so just a note here, so when square root x is the original expression or equation, the principal root results in only positive values. So here, for example, if we're just looking at square root x, it's only going to be equal to positive 4. When negative square root x is the original expression or equation, this results in only negative values. So for example, here you get negative square root x is equal to negative 9. So here it says consider the equation x squared is equal to 24. And if we're solving for a value of x and we're going to square root both sides, that is when we have to consider the plus or minus. So here if we write x squared is equal to 24, when we square root both sides, this is where we have to consider both the positive and the negative value. So here we have x is equal to plus or minus square root 24. Here, if we consider square root x is equal to negative 5, is this possible? So remember, the square root x, again, when it's the original expression, the principal root results in only positive value. So here, so square root x results in only positive values. And therefore, this is not possible. Okay. So let's take a look here. So here it says, given the following radical functions, state the domain and range of each one. And so here we see that our domain, x, is greater or equal to 1, and x is an element of real numbers. Again, either notation works here. We can also write it as 1 to positive infinity. The range in the situation, again, y has to be greater or equal to 0. Y is an element of real numbers. And so here it will be from 0 to positive infinity. Here, when we look at our domain for this second graph here, we see that x has to be less than or equal to 1. X is an element of real numbers. So here for our x values, it'll go from negative infinity to 1. And for our range, you see here that y is less than or equal to negative 4. Y is an element of real numbers. And so here we can also write it in the interval notation, which we'll get as negative infinity to negative 4. Right, so continuing on with the last graph here, we see that our domain is x has to be greater than equal to 4. X is an element of real numbers. So here we'll go from 4 to positive infinity. And then for our y values, we see here that y has to be greater or equal to negative 3, and y is an element of real numbers. And so here it goes from negative 3 to positive infinity. Okay, so here when we look at our parent function, so parent functions again are the simplest function in a family, a group of functions with similar characteristic. The radical parent function is defined again by this equation, f of x is equal to square root x. And we know for here the domain will be x is greater or equal to 0. X is an element of real numbers. So we can also write that as 0 to positive infinity. And for our range, y is greater or equal to 0. Y is an element of real numbers. And here we see that it would be, again, 0 to positive infinity. Okay, so now let's take a look at some transformations that can occur to this radical function. So to start, we have vertical translations, which are outside of the function. And so here we have f of x is equal to square root x, that's our parent function. And now we have f of x plus 3. And so that would be written as square root x plus 3. So make sure that it's written outside of the square root. And what's happening here is a vertical translation. So here we will write that it's translated 3 units up. And so our mapping notation, our x values would stay the same, our y values would increase by 3. And so here, if we write our parent function in our table of values, so y is equal to square root x, and this is the same each time, our x and y values. So for our x values 0, 1, 4, and 9, and our y values are 0, 1, 2, and 3. And here, for our transform function, we have y is equal to square root x plus 3. And so our x values will stay the same here, and our y values will increase by 3. Which will get us 3, 4, 5, and 6. Okay, so we're going to graph both the parent function and the transform function here on this graph on the right, just to compare. So we have 0, 0, 1, 1, 4, and 2, 9, and 3. That is our parent function. And then our transform function, we have 0 and 3, 1 and 4, 4 and 5, and 9 and 6. And so here, if we look at the comparison, we see that the graph of y is equal to square root x, that's the parent function, and the transform function is translated 3 units up. So this is y is equal to square root x plus 3. Here, if we have f of x is equal to square root x, and then it gets translated to f of x minus 2, we see here that we can write it as square root x minus 2. Remember, it's outside the brackets. Here, it is translated 2 units down. So our mapping notation, again, starts with the xy points. Here, again, our x values stay the same, and our y values will decrease by 2. And here our parent function, y is equal to square root x. And we'll put a table of values for that. So here we have xy, 0, 1, 4, and 9 for x values. And for our y values, we have 0, 1, 2, and 3. And then our transform function will be y is equal to square root x minus 2. And we'll put our points here, so our x values stay the same, 0, 1, 4, and 9. And then our y values will decrease by 2. So here we'll have negative 2, negative 1, 0, and 1. So here, again, we'll graph our parent function first. So 0, 0, 1, 1, 4, 2, and 9, and 3. And here, that is y is equal to square root x. And here, what we'll see again with our translated function is it'll be translated 2 units down. So here we get 0, negative 2, 1, negative 1, 4, and 0, and 9, and 1. So here we can see that the graph is translated down 2 units, and we write that as y is equal to square root x minus 2. And so if we look at a summary here, it says f of x plus c moves the graph of f of x up or down c units. So whatever the c value is, if it's positive, again, it moves it up. If it's negative, it moves it down. Okay, so now let's take a look at some horizontal translations. And so here, we see that f of x is equal to square root x. And here, again, it's inside the function, so now it's f of x plus 1. And so now it's inside the square root. So we need to make sure there's a difference, and we indicate that when we write it. So here we have square root x plus 1. That's all under the square root. So inside the root. And here, anytime that something is inside the function here, it's always going to move the opposite to the sign in the bracket. So let's just write that here. So always moves opposite to the sign in the bracket. And so if it is negative inside, it will move to the right. And if it is positive inside the bracket, then it'll move to the left. Okay, and here what happened to the parent function, therefore, is that because it's positive, now we know that it will be translated 1 unit to the left. And here, when we look at our mapping notation, so now our x values are subtracted by 1. So again, just see that it's subtracted by 1, and our y values will stay the same. So here again, if we look at our parent function, y is equal to square root x. Put our table of values. So 0, 1, 4, and 9. 0, 1, 2, and 3 for our y values. And then our translated function, our transform function here will be y is equal to square root x plus 1. So here, we know that our x values are being subtracted by 1, and our y values will stay the same. So we'll just indicate that in our table of values here. So here we get negative 1, 0, 3, and 8, and our y values are 0, 1, 2, and 3. So those stay the same. So here, if we graph our parent function again first, so 0, 0, 1, 1, 4, and 2, and then 9 and 3. So graph those first. And then now our translated function, which is shifted over 1 to the left. And so here it starts at -1 and 0, and then 0, 1, 3 and 2, and then 8 and 3. So look, something like that. And so here, again, our parent function y is equal to square root x, and our transform function is y is equal to square root x plus 1. Okay. And then here we have, again, f of x is equal to square root x as our parent function, and now our transform function is f of x minus 2. So here we'll write it as square root x minus 2 all under the bracket. And here we see that it's translated two units to the right. And so it's here translated 2 units to the right because it's, again, the opposite of what's the sign inside the root. So here we'll write it as x plus 2, and our y values stay the same. Get our parent function, y is equal to square root x. Again, our xy values 0, 1, 4, and 9 for our x values, 0, 1, 2, and 3 for our y values. And then our transform function is y is equal to square root x minus 2. Now remember here, we're not subtracting 2 to the x values, but rather we are adding 2 to the x values, and our y values will stay the same. So here, adding 2, we get 2, 3, 6, and 11. And for y, we get 0, 1, 2, and 3, which stays the same. And so let's graph here. We get 0, 0, 1, and 1, 4, and 2, and 9 and 3 for our parent function. So that's been the same each time that we've graphed it. And then for our transform function, we are going to shift 2 units to the right. And so we'll start at 2 and 0, 3 and 1, 6 and 2, and then 11 and 3. And that will be y is equal to square root x minus 2. And so here in summary, f of x minus 3 moves the graph of f of x, again, left or right, whatever the d value is, so the d units.